Hey guys, today we're going to be talking about two-step equations, what you also might hear referred to as multi-step equations. So, two-step equations honestly aren't very different than one-step equations. We just have one other thing going on. It might look something like this. 3x plus 5 equals 4. Something like that. Now, we talked about one-step equations recently, if you saw that video on my channel, and we just said we wanted to identify the inverse operation and do the opposite of what's currently happening to the x. That was really easy to identify before because there was just one thing happening. But in this case, we have multiple things. This 3, well, it's multiplying the x, right? The 5 is adding to it. So odds are we're going to want to do the inverse operation of each of these. The question arises when we wonder, which one do we do first? So the deal is, we're trying to solve for a variable. That's going to mean our order of operations actually works backwards. Now, your order of operations, you may have a mnemonic device you use for it. You might use PEMDAS. I personally use GERMDAS, G-E-R-M-D-A-S. If you're curious why I use that, check out my previous video if you haven't seen it. So that's our usual order of operations when solving equations, or evaluating equations, I should say, expressions, with just whole numbers. We use our order of operations. However, when we solve this, when we solve for a variable, it's going to invert itself. We're actually going to start by getting rid of addition and subtraction first. Then we're going to get rid of multiplication and division, or any fractions that might be in there. I'll put that too. And then, even though this might not come up for a while and certainly won't be in this video, exponents and radicals are after that. So it's kind of weird, but we do our order of operations backwards when trying to isolate a variable. So we first want to ask ourselves, is there any addition or subtraction? Well, there is. We have a plus 5 here. So we want to get rid of that. I'm going to say minus 5. We can subtract 5 from both sides. These will cancel out because they're inverse operations. And we're left with 3x equals 4 minus 5, or negative 1. Now at this point, it really is just a one-step equation, right? This looks just like those kind of easier problems. We have a 3 that's multiplying. Its inverse operation is division, so I'm going to divide by 3. These will cancel out, leaving me with just x equals negative 1/3. And I solved my problem, just like that. And for most math classes, you're probably going to want to keep that fraction just like it is. We don't often want to use decimals or anything like that once we get to this level in mathematics. So I'm going to do one more example in this video, and let's make that x over 5 minus 7 equals 2. So if we look at this two-step equation, we can notice that we have some division going on in that 5, and we have some subtraction going on with that minus 7. So we could follow our anti-order of operations, if you will. Or you can also think of this as trying to get rid of the stuff farthest away from the x first. Now, I'm not saying that's a foolproof method to solve these, but it is one way to think about it when you're first starting out. You want to get rid of that stuff that's farther away before we get rid of the stuff that's right next to it. Although I definitely would recommend just keeping this order in mind. So we want to get rid of subtraction first. Its inverse operation is addition, so plus 7 on both sides. These cancel out, leaving us with x over 5 equals 2 plus 7, or 9. Now we want to finish up getting x on its own. We have x divided by 5, and the inverse operation of division is multiplication, so we're going to multiply both sides by 5. canceling these out and leaving x on its own, and getting 9 times 5, or 45, right over here. This is two-step equations. If you have any questions about these, let me know. Drop them in the comments below. Otherwise, thanks for watching, guys, and I'll see you next time.